Okay everybody, so today's work deals with what are called two-dimensional free body diagrams. This one's on your page right now at the very top. It's a single object with 5 forces being applied to the object. And the reason this is called two-dimensional is because unlike the work we did a couple of days before you left, these vectors, these force vectors, are pointing off in 2 dimensions of directions. They're not all just left or right or up and down, but they're in various different directions. The point of these questions is to still be able to come up with a net force. So we want to put all of these forces together into one. Try to imagine it as an object, like a box, and you're looking at it from above, and there are 5 ropes tied to the object, and 5 people are pulling the object in these directions. Well, when the object finally moves, it can only move one way. It can't move 2 different directions at once. So what we want to do is we want to try and solve for what is that one direction that this is going to move and how much force is it going to move with. So we're going to combine all 5 of these forces together into one overall net force. And it's very easy to do. And we're going to do it almost the same way we did it before you left. So if these 3 forces were not there, if the question was only a box with these 2 forces on it, you would be able to deal with these 2 forces very easily. If you were pulling it to the left, 13 newtons, and to the right, 8 newtons, those are in equal and opposite directions. So you can just subtract those 2, and the answer, if the question was this easy, would be 5 newtons to the left. So let's write that down. We're going to re-simplify this diagram and make a more simple version of it. And I'm just going to sketch it down here at the bottom. So in the left and right direction, 13 newtons to the left, 8 newtons to the right. If those were the only 2 vectors in this question, the answer would be 5 newtons to the left. Now let's do the same thing, but let's look just in the up and down direction. So ignore these vectors and just look at these 3. Now if the question was this simple, 4 newtons up and 7 newtons up, you could add those together because they're in the same direction. That would give you 11. And then down is an 8 newton force. So you can easily add and subtract these 3 and get an answer in just the up and down direction. 11 newtons up, 8 newtons down. The answer, if the question was this simple, would be 3 newtons up. So let's write that in, simplifying the question more. So what we've done here is we've taken this entire diagram and reduced it instead to this much simpler diagram on the bottom. 5 newtons to the left, 3 newtons up. Now we still have to put these 2 vectors together, but the difference is you can't just add these together. The answer is not going to be 8. Again, try to imagine this is an object. If you're pulling it to the left with 5 newtons and somebody at the same time is pulling it up 3 newtons, and the box eventually moves, it's not going to move in the upward direction or the left direction. It's going to be some combination of these 2. It's going to be somewhere up here in the upper left-hand corner of the diagram. So what we want to do is we want to get an exact answer for that. So we need to put these 2 vectors together, but because they are in completely different dimensions, one in the up and down direction, one in the left and right direction, you can't just add them together or subtract them. You need to add them as vectors. And there's a catchphrase for that. It's called tip to tail. You can put vectors together as long as you arrange them tip to tail first before you work with them. What that means is you take the tip of one of the vectors and you extend the other vector from it, so that the tip of one vector has to lead into the tail of the other. So what you do is you just mentally pick one of these 2 vectors up. You don't change the direction of it. You slide it and draw it extended from the end of the other vector. So I'm going to just take that 5 newton vector and I'm going to write it there instead. So now this is arranged, the tip of one vector goes into the tail of the other. That will always form a right angle triangle. My diagram here is messy because I'm freehanding it, but it would be a right angle triangle. And now the result, or sorry, the resultant of that triangle is the answer. So side C of this right angle triangle will be the actual answer to this question. So not only will you get the actual value for the force, but the exact direction of that force as well. I'm running out of room here, so let me redraw it up here where I've got some more space. This is what we have so far. We've got 3 newtons up, 5 newtons to the left, arranged tip to tail, and the answer to this question then is going to be this here. Side C of this triangle will be the actual force and the actual direction that it will be in. So you already have the math skills to do this. You're going to need 2 things. You're going to need side C of this triangle, and it's a right angle triangle, so Pythagorean theorem, and that will give us the answer for how strong the force is. And then you'll need to calculate the angle inside this triangle to say what direction the force is in. Now you don't just randomly choose any angle inside the triangle. We want the angle next to where it started. So we're going to look for this angle here. This is the origin. The box begins to slide. It goes this way, and we want that angle. So there's 2 things you're going to do. First of all, you're going to solve side C of the triangle using Pythagorean theorem. And you know how to do this already. You've got a 5 Newton side and a 3 Newton side. So square those, add them together, and then take the root of the final answer in the end. And you get 5.83 newtons. So that is the actual magnitude of the net force. And then these questions are also going to require that you solve for the angle. So going back to this triangle, you can use any 3 sides of the triangle. You can use trigonometry, sine, cos, tan, using any 3 sides of the triangle. I tend not to always use side C, because what if you made a math mistake? It's better to go back to these 2 sides that are already there. So looking at those 2 sides, I want this angle here. I have the opposite side and the adjacent side. I'm not going to use the hypotenuse. So sine, cos, tan, OH, AH, OA, this is a tan relationship. So I'll finish the question off with tan of the angle that I'm looking for is opposite side divided by adjacent side. So tan of that angle is going to be the opposite side is 5 newtons. The adjacent side is 3 newtons. Divide that on a calculator. 5 divided by 3. Take the inverse tan, and you get the final answer for this question, 59 degrees. 59.04 degrees. Almost the end of the question. Now remember, same as before you left, you can't leave answers as just an angle, because that doesn't really say what direction it's in. It's just an angle. So you need to state that in proper compass coordinates. And if I go back and look at this, on your page it says north, south, east, and west. On my page it's just a blank paper. This is a 59 degree angle in here, so this is north, but 59 degrees swung over to the west. So my final answer would have to be north, 59 degrees west, and I'll put that in square brackets because square brackets always denotes direction. And so this here is going to be the second part of the final answer. So this is a bit of a mess, but in the end we've taken all 5 of these vectors, we've represented them as just 2 vectors, arranged those 2 vectors tip to tail, taken side C of that right angle triangle to get the magnitude of the final answer. Now I called that C, but really it isn't really side C. What that is the net force. So the net force in the end is 5.83 newtons, and the direction is north, 59 degrees west. The next question, you have 2 on your page, looks like this here. So these questions, you'll get any combination of vectors, and it doesn't matter how many vectors there are. There could be 1, there could be 2, there could be 500 vectors on one diagram. Every question is the same. They don't get any harder. Start by looking just in the up and down direction. Ignore everything else. Here, I'll put my calculator right over top of these. Ignore everything else and just look in one dimension. If the question was just 12 newtons up and 25 newtons down, it would be very easy. The answer to the question would be 13 newtons down. Simple subtraction. Now let's look in the left and right direction. If the question was this simple and only had those three vectors, they would all be in the same direction. So you could add those together. 25 and 10 is 35 and 4 is 39. So if the question was that easy, the answer would be 39 newtons to the right. So I've taken this entire diagram and reduced it just to these two vectors. Now, we still have to put these two vectors together. But again, remember, you cannot just add them. These are vectors. Direction is important. The only way that you can put the vectors together and get the answer right is you have to arrange them tip to tail. Meaning, take any one of these vectors, it doesn't matter which one, slide it over or slide one of them down, arrange them so that the tip of one vector goes into the tail of the other. I'm going to do it like this. So I'm going to take my 13 Newton vector and I'm going to slide down and extend from the end of it the 39 Newton vector. This will always form a right angle triangle. So the answer to this question is going to be side C of this. Well, my hand, I'm doing this quite messy, but first time I've ever tried to work with a video camera and sort of look over the shoulder of the view here to do it. We're looking for side C of this triangle. And so that not only is that going to be the answer to the net force, but that's the actual direction. If you go back to these 5 forces and you have 5 ropes tied to this object and they're all pulling in these directions shown, when you combine all those forces together and you get one final movement, this is the direction that it will be in. So again, Pythagorean theorem, very simple to get the actual magnitude of the answer. This is a 13 Newton triangle now. Or sorry, a 13 Newton side and a 39 Newton side. So square those two values, add them together, and take the root and you'll get the final answer. So 41 point, I don't know how many decimals to carry this for this video, but 41.1 newtons. And normally that would be the end of the question. So that is the overall net force. You also need a direction. So you need the angle inside this triangle. And again, you don't just randomly pick one of these two corners. You go back to where the origin would have been. This is the angle we're looking for. This angle here. That angle down there really doesn't have anything to do with the direction that this object would have moved. So again, I don't really trust using side C because maybe there was a math mistake, maybe not. I'd rather use these two sides because I'm more confident that these were right. So I have the opposite side and the adjacent side. Again, you're going to find that in physics, 90% of the time, when you do trigonometry to solve problems, you end up using tan. So this is going to be tan of the angle will be opposite over adjacent. The opposite side is 39 newtons. The adjacent side is 13 newtons. And take the inverse tan of the right hand side when you divide it. And you get a final answer to this question of 71.57 degrees. And again, you want to finish this off with a compass coordinate direction. So that's not just 71.57 degrees. It's south, but 71.57 degrees swung over to the east. So I would finish this off with south, 71.57 degrees east, and square brackets. Now, if you go back to the original page and look at this question goes a little bit further because it asks you, if you applied this force, how long would it take for the object to move 10 meters, starting from rest? So this question goes a little bit further. These are the two answers to what I've done so far. The net force is 41.1 newtons. The direction is south, 71.57 degrees east. We don't need this anymore to continue the question, but we are going to need the net force. So where do we go from here? Let me grab another sheet of paper and put this under the camera. So remember, force equals mass times acceleration. Oops. So you can always solve for acceleration when you have force. And that's the whole point of these questions. Put all the forces together and get one overall force so that you can use this formula and solve for acceleration. So acceleration will be force divided by mass. Our final force, when they were all put together, 41.1 newtons. The mass, you may not have noticed, is given in this question. If you look inside the box on your page, it says 20 kilograms. So you can easily divide these two numbers and get the acceleration that this force is going to cause. And I'm going to leave it unrounded for now. 2.055 meters per second squared. So now this goes back to the work from long before the break. You've got more than enough to go back to the 5 acceleration formulas because, well, let's do a full givens list for what's on the page. It says the object starts from rest, so V1 will be 0. We are going to find out how long does it take. So time is going to be the unknown. How long does it take for the box to move 10 meters? We don't know V2. That's not given in the question, but we do know A because we just figured it out. So A is 2.055 meters per second squared. So use that givens list. Look at your 5 formulas. Look for the acceleration formula that has no V2 in it. And it's going to be this formula here. D equals V1t plus 1/2 AT squared. You have to solve for t. Now you can't rearrange that formula for t, but in this question, luckily V1 is 0, which will make that whole part of the equation 0. And then you can sub in numbers or rearrange. I'm going to rearrange. If you rearrange this, time will equal distance divided by 1/2 A. And also the root of that. You'll have to either rearrange the formula yourself or substitute in values and start to play around with it and see if you can get the answer from that point. But I will just sub into this. So the distance is 10 meters. Half is half. And acceleration, we know from the previous formula, is 2.055 meters per second squared. And so do the math, do your bed mass. Make sure you don't make any mistakes. 10 divided by half, and also divided by 2.055, and then root of the answer in the end. So follow along on your calculator. The final answer is 3.12 seconds. So that, if you've followed along and you understand all these steps, that's quite a long calculation that covers everything we've done in the last couple of weeks. So there's some practice questions on your page to try. None of them are any harder than these examples. And there are answers provided on the bottom of the page, and not just final answers. I put sort of little checkpoint answers so that you can make sure you're getting values along the way. And that's going to be it for today. A couple of practice questions, and answer or ask any questions online on the webpage, and I'll respond as quickly as possible.